first, we'll start with Wake Up Labs.
Okay, thank you. Thank you, everyone. Thank you for letting us presenting. I am Milton, co-founder of Wake Up Labs. We are working now on the AssemblyScript SDK for Stylus, for any AssemblyScript or TypeScript developer to build, be able to build on Stylus. We are making good progress. We will do our first demo here. So now the idea is to show progress, to let you know what we are building, and yeah, show you what's going on and how we will continue with the project. I will let Fran from our team, who will show you everything. Fran, all yours.
Thank you, Milton. Hi, everyone. Thank you for being here. Let me share my screen. Can you see my screen?
Yep.
Yeah, thanks. Okay, at Wake Up Labs, we've been building a toolchain to let developers write Stylus contract in TypeScript. We think more developers could build on Stylus if there was a lower barrier to entry for those coming from TypeScript. To do that, we first had to understand what was missing, what makes writing contract in AssemblyScript hard today, and how can we solve it. We ran into three main problems. First, type limitation. Stylus needs support to big integers like U256, but AssemblyScript only goes up to 64 bits. We had to implement those types ourselves. Second, tooling. While Rust has cargo stylus to handle everything from build to deploy, AssemblyScript had nothing like that. And third, setup. Every contract needs custom code to wire the entry point, decode the selectors, and make it run. It was repetitive and easy to get wrong. So we started building the tools we were missing. We focused on solving three challenges we just saw, building three key pieces. First, type transformation. For complex types like U256 or address, we built custom transformer that know how to emit valid low-level assembly script. They also handle edge cases through a fallback system. Second, the toolchain. It takes your TypeScript contract, parse it, and build an intermediate representation, and transform it into low-level code. The CLI also scaffolds projects and integrates with cargo stylus for deployment. And third, the developer experience. You write clean TypeScript, and we take care of generating the stylus-compatible WASM. No need to deal with selector decoding or manual entry point wiring. So that's the structure we built. Now let's see in action. Let me share my code editor here. So this is the structure of the project here. And if we want to create a fresh project, we need to run the following command, npm run generate, and the name of the project. That will be a test. So with this command, we are generating a new project with this style of TypeScript. It's a class with functions and decorators. The decorators we can use to set the visibility, for example, of each function. So now with this to this contract, we need to run the following command, npm run build, to create the low-level assembly script code. So how we have two files. One is this, that we transform the functions to use pointers and memory allocation, and primitives defined in AssemblyScript. Another file that is entry point here that we use to read the arguments, initialize the memory, and handle the selector. And for example, if a function has visibility view, we need to write the result. So now we need to go through this project here and run npm run compile to generate the WebAssembly code. Now we need to check our WebAssembly to Stylus VM npm run check. We need to hide this. Okay, it's checked. And now we're using this private key that is well known. It's not for use in production. And deploy our contract in the Stylus VM. So now the contract is deployed, we can interact with the contract. So replace here. And first we call get to know the value of the storage variable using cast, right? So it's 0. For example, we want to use this to send a transaction to increment the value. This transaction is success. If we get the value again, we receive 1. And if we decrement the value, sending a transaction, we call again the function get, and we receive 0. So that's the full cycle from TypeScript to working Stylus contract, build, deploy, and running locally. Let's now take a look on what's actually happening under the hood. This is a diagram with the explanation. It shows the full pipeline, how TypeScript contract gets turned into WASM. It starts with the contract itself, which is parsed using tsmorph that give us a fully typed abstract syntax tree, or AST. We pass that AST to our analyzer, which walks through the code and extracts all relevant statement and expression. From there, we generate a clean intermediate representation, or IR. This step strips away TypeScript syntax and gives us an structured foundation to work from. Next, the IR is passed to the transformer layer. Each transformer handles a specific type, like U256, address, or string, and knows how to emit valid AssemblyScript code that follows Stylus constraint. The result is a full AssemblyScript contract ready to be compiled to WebAssembly. Finally, we compile the code and deploy it. The entire pipeline is automated by our SDK. You write TypeScript, and we handle the rest, from parsing to transformation to deployment. So now you've seen the full pipeline. Let's look at where we are and what's coming next. We started with research and core development, building modules like memory, storage, and host binding to lay the groundwork for Stylus. Right now, we are in the compiler and SDK setup phase. As you saw in the demo, we've already added support for visibility decorators. For example, with View, the compiler knows it's a read-only function and automatically adds the right result logic. So developers don't need to write it manually. We're currently working in 2 fronts: validating the contract syntax and structure so the compiler can map each function to its correct low-level transformation, and implementing low-level primitives for types like U256, so we can safely lower high-level TypeScript into optimized AssemblyScript. When this is done, we'll move on to standard contract templates like ERC20 and ERC721, and continue improving stability, tooling, and test. So thank you all for being here. We're really excited about what this toolchain enables for the Stylus ecosystem, and we're just getting started. If you have any questions, thoughts, or want to dive deeper into anything we showed today, don't hesitate to reach out. We are always open to connect.